Right, so let's get started. Like I said, it's just a short lecture today. Let me start the share screen here. All right. So we have talked about the theory. We're done with that. So hopefully, this exam today will be about theory, certainly. Understanding the transformer as much as possible is important. But you've already done your presentations on pre-training a large language model, a GPT, and you saw basically the results of that. Even, you gave it as many books as you could, still you can't get to the level of a GPT-4, not even a GPT-2 for that matter. All right, so that means that we have to use transfer learning, basically, right? We have to use transfer learning, and that means we have to use the concept of fine-tuning, right? Now, you guys still have, that was a homework assignment, the GPT. Now you guys have a mini project, which is the reinforcement learning through human feedbacks, right? I've already given this to you guys, but you could think of this as either very hard or easier. It just depends because you will be using Huggingface, right? So we have to use Huggingface, these transfer learning libraries that we have available, right? So there's several of them, but at the end of the day is we do the transfer learning. So today, the topic of discussion is a couple of things. We're going to go to Scholar. Right, yeah. So we'll go here, get in Scholar, play with this a little bit. I've already loaded the code, so you can get it from the course repo at Transfer Learning, Huggingface Transformers, go to 2024, and then in here, GPU required. So go there. So all of these, everything in here requires a usage of GPU, otherwise you will not be able to get it to work. Right, so basically I'll tell you what I have in here and then what we're going to focus on today. So I just have a few scripts. These run in less than 30 minutes on a GPU, the V100. So you should be able to get it to work. I'll kind of give you how I think you should approach this. That's basically what it is, okay? So we'll talk about that. So I have this example, fine-tune example. I should have called this fine-tune example GPT. I forgot, but that's basically fine-tuning a GPT. Remember, you did pre-training, right? You took code from scratch, you took a whole bunch of books from Shakespeare, pre-trained it, and then you gave it prompts and looked at the answers, etc. That was pre-training. You should understand that concept. If you gave it all the books in the world, all the text in the world, all the GPU power in the world, you'd have GPT-4, right? Or you would have Llama 2, something like that. All right. So you don't have that resource, unfortunately. So then the next best thing is to use transfer learning and a library such as Huggingface. So we then here in these examples, we're going to download GPTs or BERTs. You know what those things are now. So we're going to download pre-train either GPTs or BERTs and then basically fine-tune them. So that means that we're going to do additional training for our task. Now, remember, we can just give them more text. So for instance, like we have all the text in the world, but then we just want to focus on Rick and Morty or, Harry Potter, right? So you can give it all those books and fine tune it towards that. Or we can fine tune it for a specific task like sentiment, like making something sound more positive or more negative. Or we can actually fine tune a BERT or a GPT to predict things like a class or even a value. Remember that in the RLHF, you need a BERT that actually just predicts one number, right? Let's say from 0 to 1 or something like that, a score. I will give you a paper about that because that's the additional thing that we kind of now need to dig in a little bit deeper, right? So it's actually one of the challenging parts of the RLHF mini project. Where are you going to get this reward function? Okay. So we can fine tune a model, a transformer, either to just speak more text, or if we add these heads like we do with other models to predict classes or to predict actual numbers like sentiment, like positive or negative. Okay. So today I will discuss basically this fine-tune example GPT and this fine-tune example BERT. And basically just to show you how you can now take models and fine-tune them using Huggingface. All right, next week, I will get more into this idea of text classification and the RLHF. So another thing next week. But that's basically what's in here. Okay. Now, I also have these 3 examples, and that's actually where I'm going to spend most of my time today. This is Huggingface fine-tune, but loading your own data. All right, that's really the challenge with these models, okay? Because a lot of the code is already super optimized to be very simple, right? So I'll just explain kind of how Huggingface approaches this process. So remember, we're no longer writing things from scratch. Instead, we're importing all the functions that Huggingface has available, and we're going to try to use them. So really, all I'm going to explain is how that works, okay? And then this ResNet 1 GPU, that's me just doing some other things for a later topic, not related to RLHF. All right, so my goal right now between today and next week is RLHF, right? Getting to that point. Currently, it's fine-tuning. Remember that RLHF is fine-tuning, plus there's the additional reinforcement learning part, right? That's it. So today I'm just doing the RLHF without the reinforcement learning, if that makes sense. Got it? Yeah. Remember that what you're trying to do is you're trying to modify a GPT to still produce text, but produce it in some way, either in a format it's a question and answer, or to make the text more positive or negative, right? That's the example that we had. So obviously that's not what you guys will be doing. I haven't set a date for this, but I think by next class I will. Okay, I depending on, you know, the discussions that we have, you know, and then you guys we can maybe even set up some time. You should start thinking about what your data is going to look like for the RLHF mini project. Got it? Yeah. So it's the idea is like, and just to remind you, if you've forgotten, ChatGPT, right? So ChatGPT was basically, you know, pre-trained, fine-tuned, etc. But before RLHF, it still can't answer questions. You say something and it's going to drift and it's not going to be great. So you have to do that additional RLHF to get it to now, okay, this is a question, I'm going to produce an answer. Or if somebody gives me a task, I'm going to perform the task. You know what I mean? You shape the text to look more like what you want it to be. All right. So anyway, so that's kind of the idea. So this is the code that we're going to discuss. So fine-tune GPT or BERT. Basically, you can see this is I'll start running this, but I kind of want to just speak about it here, and then we'll start doing this on GPU Scholar. So basically, the trick is that you have some text that you're going to download, right? And you're going to use that text to do the fine-tuning. In this case, it's very simple. It's very simple, either GPT type or BERT type, right? There's nothing beyond that. So it's really what you understand a GPT to be. In the GPT, we give it 2 inputs, right? Or sorry, 1 input and no, sorry. The input and the output are the same, except that the output is shifted, right, by 1 word. That's a GPT. Remember that? And in a BERT, you have the input and the output is the same, but now you put a mask. So the goal is for it to predict 1 word. That's all we're doing here. And so the trick is, how is this data fed into the Huggingface libraries? You see, that's really the hard part, okay? And so what I will do is just kind of describe how they did it. And so obviously, you guys are not going to go in and try to change the Huggingface code, right? So that would not be a good idea. So instead, what you have to do is you have to understand how data is fed, you know, the format of how the data needs to be fed into the Huggingface models. You see what I'm saying? In libraries. And if you learn how to do that, then when you have your own data, you just need to format your data to be what Huggingface is expecting. That's really the trick. Got it? Does that make sense? So that's really what we're going to talk about today, is kind of look at I'm really just going to give you like the procedure you need to follow to kind of understand what the data looks like, so that you know how to create your own data and then feed it in to the trainer. So that's really important, right? So I want to go over the logic here. I started with this example, I think. Yeah, the fine tuning. So this is the GPT. So I'll just kind of go over it like a broad overview of it first. Okay, so notice here they're using their own datasets library. So the advantage of this is that this is already formatted. Okay. So, but here is kind of the code, and I'll do some examples later of how you feed your own data from a text file. So I'll create a little text file and I'll show you guys how it's fed basically. All right, and what it looks like and how we can debug it. All right, then notice this function here just selects some random sentences, prints them out. Their data set has a train, a validation, and a test set. Okay, you can see basically it's just pure text and an index. There's nothing else going on. So this is the text. Then after that, remember, you've done some of this already because you've done already inference, right, with GPTs and BERTs. Inference is just taking a model and using it like a black box. But now you need to start fine-tuning the model. So you still grab, using the Huggingface pipeline, you still grab something like here we grab a GPT-2 and we grab the tokenizer. Remember, there's always that duality that exists, right? So we load a checkpoint from the Huggingface repo. We have the tokenizer. Remember, the tokenizer just takes the text and converts it into integers, right? Don't forget, that's how it works. Okay. And then here, this is, you know, they have these functions called map for mapping things. Okay, but the nice thing about this is you can still use this function because you'll take your data and read it into a data set, right? So basically the idea here is, if we go back, is that you use the function load data sets from data sets. So that's going to put everything in the format of Huggingface, and then you can use all of their functionality. Make sense? But the key thing is to get those text files exactly as they need them, okay? So that's going to be the hard part, and it could be very hard depending on the data set that you select. So think about that carefully, because in data science, usually that's the hard part, right? It's getting the data to the right format. All right, so this is the text here. So you can see they, by default, already convert things into the input IDs and the attention masks, right? And the attention mask here, what just indicates how many values you have. So 1, 2, 3, 4, 5, 6, and there's 6 ones there, basically. So it's indicating that's all you need. After that, they take over. And basically, if you're doing GPT, it'll do the mask how it needs to be. If it's BERT, it'll do it. So really, you know, it's convenient in a way, although it can be complex sometimes to understand what's going on. And then basically this function is actually a function that took me a little bit to understand what they were doing. Okay, so but I'll describe it later, and it kind of makes sense. So it's very straightforward actually once you really see it. So anyway, the important thing is group text is the function that is going to put the data as the GPT model needs it, okay? We'll discuss it later. But what I want to address is starting from here, from this cell. So notice that they're going to use the tokenized data sets. They're going to use this map function again, and they invoke this function group text, which is this one, and that will create the data set as the Huggingface library needs it to be, okay? Once you have that, then, you know, basically they have this, right? So this is what actually creates the data set, which is called LM datasets, okay? That's it. Once you have that, then you can start training, okay? So a lot of these steps so far have just been data processing, which is confusing, granted. All right, once that's complete, and this is what I'm gonna, when we go to the Scholar, I'll describe it in a little bit more detail with the other scripts. But I really want to focus on, once you have the data, let's say in the right format, what is the basic pipeline of Huggingface? So this is just an example because these are integer IDs, so it just shows that it's, you know, what the text looks like. So anyway, here, notice you load the model and the config file, right? Some config file, right? Then you go in here down here and you define the training arguments that you're going to need. And this is something you do need to modify. Okay, maybe. So the learning rate, weight decay, and all that, that's default. The push to hub just means that if you create your account on Huggingface, it would push it once it's trained to the Huggingface. You don't have, I did false, so you can see I turned that off. This is important, and I think I had mentioned this last week. The way that Huggingface works is that it's creating the checkpoints for you. That's great. I mean, it's a great thing that it's creating the checkpoints. But remember that you're using GPT-2 and you're fine-tuning GPT-2. So, and it's creating several checkpoints. So they're big. Okay, you know, this might be, and the whole training might be like 5 gigabytes or something. All right, so that you don't run out of space, and because if you run out of space, the whole process will break. I recommend that you guys use the scratch space in Scholar, okay? So all you have to do is, when you're doing training arguments, you're gonna be creating these model checkpoints. So just append in front of it the full path to scratch, okay? This is, of course, if you're running on your own GPU box, then, you know, it's whatever, how much hard disk you have available. But for those of you that have to use GPU Scholar, just add scratch, Scholar, and then this will be your username, basically. Okay? And that's it. So if you do that, all your checkpoints will be saved there. And I believe we all have 1 terabyte of space. So that should be enough. Delete it when you're done. Okay? Questions? Yeah. So that's an important thing. And then the other thing that we have to get used to, and this is also true for the RLHF, is that Huggingface creates this wrapper called a trainer, okay? So you're gonna deal with these trainers when you do your mini project. So the trainer is very convenient because it just takes everything, but you have to make sure that everything's correct. So like this would be just a Huggingface model. These are the training arguments, which is basically this one over here. And then these are your data sets, train and test. So as long as you've converted everything correctly from this step, you're good. Do you see that, guys? So that's really what I want you to understand with fine-tuning. I suggest that this is not homework, but, you know, as an exercise, run these scripts on your own, okay? Run the fine-tuning first, and then you will see the RLHF is similar because there's also a trainer function in there. You guys understand what I mean? Key, though, is the data, all right? The data for the RLHF might need to be further manipulated. So that's really the hard part. And as I said, with RLHF, you do need the reward function. So you need to solve that in some way. You could train your own reward function. That's a possibility. That would be a nice project. But my suggestion is if you find one already, you know, one available on the GitHub, on the Huggingface hub, use that one. Any questions? Is all that clear? That's basically it. I mean, after this, if you notice, once it gets to trainer, it's pretty straightforward. You know, you give it the model, the training arguments, the train and test set, and then you just do trainer.train. And if you have a GPU, it's going to start processing things. That's it. That's kind of it. Now, there's a lot of metrics that are available for these kinds of things. So in 520, you guys learn about precision, recall, F measure, or the R square. That's when you're training models like pre-training. That doesn't apply here. Okay, so the metrics for this, I need to provide another paper for that for you guys to look. It's just a lot of metrics. Like I can give you one that I've worked with, which is called the BLUE score, and it's for language translation. All right, so it's just basically something that is kind of based on word error rate, but more advanced than that. And so these are the kinds of metrics. They're very specific to the task, and it's what is used in the benchmarks and things like that, okay? So for this one, this just has a perplexity score, and basically I was just comparing this to what they have on Huggingface, and mine was similar to it, okay? So unfortunately for these, I mean, I encourage you to use metrics, but I won't be asking you for metrics for your projects. you know, more than anything, it'll be a qualitative analysis, kind of like what we did with the pre-training example. You'll just, I did this, you know, and these are my results. Hopefully better than just the pre-train, right? Any questions? Does that make sense? That's it. I mean, that's actually the pipeline. So it gets really easy as you're getting to the end. What's difficult is definitely getting the data in the right format. Okay, so that's kind of what I'm going to discuss next is, you know, how they did it, what I noticed there, and also loading my own data in there. But yeah, for the most part, hopefully they are, you know, you won't, once you get to the data in the right format, RLHF should just be steps similar to these and having that reward model. Questions? All right, so that's basically it. I have the BERT model also here. So if you look at the BERT model, it's similar. It uses the same data actually. You know, notice I changed again, the path, training arguments, trainer once again. Oh yeah, I'm glad I looked at this one. So this, you might encounter this called the data collator. So this is an additional thing that exists. It's basically like when you want to process the data a little bit more, you'll have these. And I believe RLHF does have this. If you notice, this makes its first appearance right here, okay? So you basically, from transformers, import a data collator, and then you invoke it. But if you notice, what it does is it's basically going to do additional processing of the data while training is happening. You guys see that? That's its objective. So it's a thing that you pass into the trainer. So basically, if you remember in the GPT, we just had the model, the training arguments, and the two data sets, and that was it, because we didn't really need to do anything. In fact, the Huggingface library also does the shifting. So if you notice, the data, the input and the output are actually the same for GPT. And inside, they do the shifting. So you don't even have to worry about that. But you need to be aware that they're doing it. But in the BERT, you want to do something while it's training. And that's why you create these things called data collators, okay? So basically, in this example, because it's a BERT model, it's doing MLM, which is masked language model, right? So it's the masking. So basically, you provide this rate of 0.15, and it's going to mask some of the words, 15% of the words randomly, basically. You guys see that? But they want that to happen during the training. And that's why they have this functionality that they've created. Any questions about that idea? So if you encounter this, just be aware this is what it's doing, okay? So if you notice, they pass this collator, which makes its first appearance here. Here they just have the same things, you know, this learning rate, weight decay, all that, trainer.train, and then, you know, some kind of a perplexity, which is basically just, you know, some metric that they're using. And that's basically it. You can see it's supposed to be low. So I got this from the Huggingface. So basically they're saying they want that to be low. But anyway, that's kind of the overall pipeline of fine-tuning with Huggingface transformers, okay? So a lot of it can be easy as long as you have the data in the right form. Any questions? All right, so now I'm not hearing any questions. Let's go to the Scholar. You don't try to get a GPU, because especially before I do this, because then I won't get a GPU. Let me get one, and this won't take that long. And really, I just want to discuss the data set and kind of show you this example of, like, I'll create my own files, it'll read them, and that can give you some insight into that, okay? All this code is posted already. All right, so if we go here, all right, so if you notice, I was playing with this a little bit. So these three files, HF, fine tune, load, own data. So basically that's what it is. And then just one is just GPT. Then I wanted to do the GPT and BERT, and then I just GPT and BERT, and I looked into this grouping function in a little bit more detail to see what they were doing. It's a good insight to understand what they're doing with the data, okay? I would suggest you do that. Don't just like, okay, I'm gonna feed the data, especially for the mini project. Instead, look at those functions, print out what's going on, get a better understanding of it, and it'll save you time probably in the end, even if it takes a while. All right, so let me try to get Scholar here. All right, so as you can see, I'm just using the same document. I'm going to scroll. Here. All right, so I'm going to request the Jupyter notebook. Okay, so hopefully I'll be able to get one. Okay. All right, great. So we've got the Jupyter. So I'm going to click on this. Okay, I'm going to go to desktop. All right, and I have the scripts here already. I also want to show you when you go over here. I don't know if I had shown you this before. You can click on cluster, Scholar shell access. And then you have your shell access here. So you can do, I think clear works. Yeah. My quota. And basically you can see I have 35.7 gigabytes already in Scratch. And this was just me running these scripts yesterday. That's 35 gigs. Okay. Just for, these are the checkpoints basically. Okay. So you can probably get rid of this. So if I do ls, that's going to be Scratch. So. Oops. All right, so you can see it's all of these, the GPT-2 wiki text and the test CLM. So if I do my quota, right, that's the 35 gigs. You can remove it because you're the owner. So just do -R and then GPT-2. All right, and then do the same for the test CLM. Right, if we do my quota, right, it's at 827 megabytes. That's probably the other things, which are kind of small. So you can control how you're filling up this Scratch space. Keep in mind, this is a temporary storage, so they will delete this. I don't know the policy for it, but assume quickly, right? So this is mostly for this kind of thing. All right, so yeah, so that's kind of something I wanted to show you. Now let's go back to here. Okay, so these are basically the scripts that I was playing with. So I have these fine-tune BERT and fine-tune example. This is the GPT one. We're not going to cover this one today. And then basically this one, fine-tune, load, own data, GPT and BERT. It's the one that I'm going to discuss now. As I said, basically this is just me looking at how they process the data and also providing an example of loading your own data. Okay, So let's start with that. So if you notice, I created these two text files. You can, if you want to create a text file here so that you can quickly get going, you can always just go to new and then text file. And that can really quickly get you set up, or you can upload it or something. Right. So anyway, I have these two files. I just did this for RC train and RC validation. So if you click on RC train, you can see all it. This is basically the format that I used to I didn't fine tune with this data because I don't have a lot of data, right? So obviously you would want to add many files in there, but you can see basically it's loaded like this. So it's basically like a sentence. Oops, sorry. A sentence, hit enter. Second sentence, hit enter. Third sentence, so on. Couldn't be easier. This is not JSON or anything like that. This is pure text file, and it can take it like this. Got it? That's it. For the way that they expect it to be. Keep in mind, for a GPT, they will actually create just one very long string, remember? And then what are they going to do? They're going to pick IDs, create chunks, chunk them out, make them input and output, shift them, right? That's kind of what the process was. It's exactly like we did it in the GPT from scratch. So go back to that procedure. It's the same one. Only they do it. And so they do it differently than, So anyway, but this is your text file. So if your task was to fine tune GPT or BERT, you just load your data like this and that's it. Do you see what I'm saying? But when you do RLHF, you have to then do the same thing. Look at how they formatted the data and format yours in that same way. Any questions? Making sense? Yeah. So I think honestly, it's easy to work with Huggingface. It's just that the data, you just got to know how they want it to be, basically. But it's very flexible. And I did provide, I do think I provided something else. If you go here, I want to say I did this. Yeah. See this one, in the same repo where I do GPU required, where load your own data, I provided this link here. This is the link to load your own data from datasets in Huggingface. So this is load text data, okay? So you definitely want to read up the documentation that they have, as this will be, in my opinion, one of the hardest parts of the mini project, either this one and the reward function. Any questions? All right, great. So you can take a look at that link, your own convenience. All right, so you saw this one. I'm going to close it. Now we can look at RC validation. It's pretty much the same one. I just added like random letters in there, but you can see that's the format. And from that format, you can load your own database. Okay. All right, so I'm going to go ahead and close this one as well. So now that we've discussed that, let's go ahead and take a look at this file. Okay, so this is the file. All right, so I ran this already, but I'll kind of run it again. And together we can talk about it. Okay, you can help me out but basically all I was doing, to be honest, is just kind of like working through all the functions, all the lines of code, and just like, oh, what are they doing here? And, oh, okay, this is what's going. Oh, this is what this is. You see what I'm saying? I was just going through that process. Okay, and you can see basically a lot of it is just, looking at the text and the information. Yeah, exploring the grouping function. So this took me a while actually to kind of get a feel for what they were doing. I just wanted to convince myself of what they were doing. And so I provided some examples of like what this part of the code is doing, things like that. But once you can see that once they do this, that LM generation, LM data sets, that's basically the process. I didn't change anything after that. It's just really, setting up the training arguments, setting up the trainer, train. And then I just repeated the same process for the mass language model. Okay. Yeah. All right. Great. So I'll we have plenty of time on the GPU. So I'm just going to go through this step by step, and we can kind of discuss it. And this is what I recommend you guys do for the RLHF. Take your time understanding that example, the data, what they expect, and so on. Okay, so we have plenty of time. So let's go ahead and I'm going to reset the kernel here. Okay. So that should, all right, so there it is. It's reset. So basically, I'm going to run through these functions one at a time. Wiki text, I believe, is from Wikipedia, if I'm not mistaken. All right, I did take some of their, this is basically one of the examples that they have at the Huggingface repo. These change a lot. So like having a book from 2 years ago, it's all obsolete because they're changing all the code. I don't recommend you guys do that with these kinds of libraries because they're changing all the time. And so go to actually the Huggingface, get the examples from them. All right, so I'm gonna go ahead and read this. All right, so notice from datasets, import load dataset wiki text, right? So here, let me. All right, so it worked. So there it is. So this basically says, you know, causal language modeling. So causal language modeling is a GPT, right? So people autoregressive models, when you predict and you use the input, you know, causal is also CLM. So the model has to predict the next token in the sentence. So the labels are the same as the inputs shifted to the right. To make sure the model does not cheat, it gets an attention mask that will prevent it to access the tokens after a specific token that you're trying to predict. We discussed this last week, right? So you saw that. And all of this is handled by Huggingface, so you actually don't need to worry about it. All right, so then I'm going to run this one. That's data sets there. So you can see basically that data set, which is coming from the Huggingface datasets module, has a test set, a train set, and a validation set. It's really a dataset dictionary as an object of Huggingface. And then it's got this feature called text to indicate that it's text, because it could also be input IDs, it could also be labels, it could also be attention masks. So these are like the basic things that they have in there. This is the number of rows. So the train set has 36,000. This number changes, interestingly, okay? So we'll take a look at that. You can print it, you know, data set train. So there it just shows one of the things like the train set. This is the example. If you want to look, this is basically like slicing, right? So you can just slice a few sentences from in there. So notice in there you got the featured text, and then you've got the game takes place during the Second European War. Notice that they do have these new line characters. I actually looked at this, and when I put the enters, it did not add them in here. So it's like they had to be in there to end up here. One other thing that you should notice is they already did this. Like in a normal sentence, you'll have soldiers, period. But they already did the tokenization where the periods have been separated from words, okay? Keep that in mind. So what I'm trying to say here is that there is some additional pre-processing of the text that they have done. And you guys can choose to do that or not. I'm not really like, because I think the key thing with your project is use a lot of data. Now, when I say a lot of data, I mean like 100,000 sentences, right? I don't mean more than that. Fine tuning, remember, there's a huge difference. In pre-training, all the text in the world. But in fine tuning, I hear or people say that to train ChatGPT, it was only 100,000 pairs of questions and answers. That's what the rumor is, right? But they haven't said. There's no published paper on it. So nobody knows, but it's It might be true because it's high quality text. That I do know. And I've heard that they did another project of very nice project that I really like, where they have high school math problems and high school and the solution to it, all in words, right? So like in high school, you have a math problem, and then you write the solution to that math problem. They did that also with or they're trying to do that with RLHF, or they've done it already. I'm not sure, but they only use 8,000. Problem and the solution, 8,000, but really high quality. So my point again is fine tuning does not require as much data as pre-training, from 8,000 to 100,000. Okay. All right. So anyway, this is the example here. Remember that one difference is that here it's only one given sentence, right? For RLHF, you may have question and answer, this and that. You have to think about it, how you're going to do that. Okay. But anyway, this is what the data looks like. Any questions? Nope. All right, great. So we ran that part. We can run it again. Now notice the next example is just me showing you how you can read your own data, right? So I created those two text files. Notice that I did have to put in the full path here. So the full path is home, my user, and desktop on the GPU on Scholar, okay? And then notice I'm bringing in RC train and RC validation, which are these two files here. So basically this, you can put your data there, and then this is how you would bring it in. So, and the nice thing about it is you definitely want to use their load dataset module, so everything starts to look like what they need. Got it? All right, great. So I'm going to go ahead and run this one. My own data set. Notice now it's in the format. You have a train, a validation set, text, number of rows 4. If you compare this one to the previous one, you'll see that they look similar. And that's it. That's how you can, at this point, you start to get your, for this example, it's easier, but you're starting to get your data into the appropriate format. Okay, perfect. All right, so we've done that part. Then I just started, as I said, I mean, the majority of this is just going over the data set, taking a look at it. Notice I'm just looking at it, it's just slicing everything, right? So I got 4 in here. I'll do that for the validation as well. Okay, and I'm looking at it. All right, then after that, this function that they have in there is just to select random. So this function is actually it's not necessary actually for this to work. This is more for show. Code is straightforward. Randomly creates a list, picks, randomly selects, picks it hasn't selected, and then it has a list of 10, basically, sentences, converts it into the data frame for those IDs, and that's it. You print it out. So this was me they're just here checking that it's the right data type. That's all they were doing. And then here they just converted to HTML. So it's actually not really, this function is just for that, for showing the data, basically. Doesn't do anything to it. All right, so you can see there, I ran it here. And it's basically just a sentence and the numbers, okay? And then this is the HTML part is what makes it look like that. Got it? So that's pretty straightforward, just looking at the data, not really relevant. This is getting the GPT and the tokenizer. Now, I wrote this because I thought it was a good note. You have to really, in that example of RLHF that I provided, read the little notes, okay? Because they'll have important things. So for causal language modeling, we take all the text in our data set and concatenate them after they are tokenized. Then we will split them, split in examples of a certain sequence length, right? This way the model will receive chunks of continuous text. So the input and output is what they mean, which is of size 128. Notice here, the labels will be the same as the inputs, okay? So the labels will be the same as, I think I miswrote here, but you don't have to shift them. It's shifted by the Huggingface library. Okay. All right, then you grab the tokenizer here. This is the function that grabs the tokenizer, given some text, it converts it into integers. Okay, the IDs, this is exactly like the pre-trained from scratch that we did. Similar. Now notice again, then they do these things. They have the data in datasets. Datasets has a built-in function map, and you can give those functions, right? And they will do the processing for you. So if you want to maybe tweak, you would tweak tokenized function, but you maintain the rest of the pipeline as is written by Huggingface. Got it? But but that's up to you guys. Okay. Okay, now tokenized data sets, right? You can see this has changed. Now it's no longer the text that was removed. And now what you have is input IDs and the attention mask. And notice that it does it for you, okay? So this is why at this point, it starts to make sense to, just start with the format that they want in your text, and then everything should work, okay? And then you can see here, this is just, try several indices if you'd like, just to look at, you can see now, not all sentences look like this. This is actually one, most of them are long, right? Because they're almost like a paragraph. So there's going to be a lot of IDs in there, okay? Now, block size just means that the sentence length is going to be 128. And then you get into group text. This group text is actually a little bit complicated, I thought, when I was reading through it. But it's basically just taking all the sentences, right, that you have in that are lists of IDs. And all it does is it concatenates all of it into one single list. Okay, so you have like sentence 1, right, which was a list of 5 IDs. Then sentence 2 is a list of 57 IDs. Then sentence 3 just has 3 IDs. Sentence 4 has 100 IDs for whatever reason, right? Each of those is a sentence, but now represented as IDs, and they're lists. So it's a list of lists, basically, is what this code is. And all it does is it converts a list of lists into just one list of IDs. So it concatenates them, basically. Got it? So that's what this is doing. As I said, hopefully these functions you can keep as is. For the RLHF problem, you will be doing a GPT. So that, if you remember, that's kind of what you're doing, right? So this is relevant to that. So here is basically the idea. So it does all of that. It concatenates it, and it creates the data set. So I have this broken down further into the individual functions. So we have here, and then, as I said, this invokes this function and performs the mapping. Okay, finish. LM datasets then is there. And you can see now it added a new thing called labels. And what is labels? If you notice, it's just input IDs, but a copy of it. Why? Because you have the input sentence and the output sentence that will be shifted to the right. That's what that is, okay? Does that make sense? Remember, you'll give it the input IDs, the GPT will do its thing, produce IDs, and those IDs get compared to labels, take the loss, back propagate. Okay, we talked about this. So that's basically all that's happening. All right, so notice the labels is there. So now I just started exploring that grouping function to kind of get a feel for it. So what is data set and key? So if you notice, here you have 4K and example.keys. So what's example.keys, right? So I recommend you guys do this when you're going through the code, right? Explore the functions, get a feel for them. You can see that that's just test, train, and validation. So then, at 4K, right? If you notice over here, 4K, and then it just does this. I was like, what is that? right? Maybe you guys know this function. I was not familiar with this function because it's a sum, but it's also a set of dictionaries. And it's like, what is it doing? It's actually a concatenation. That's what it's doing, right? So you know how you take string 1 plus string 2 and get string 3, right? You concatenate hello plus world, hello world. That's what this is doing, but for lists. And so I broke this down in an example down here. Oh, I haven't run it, I guess. Where is it? Oh, here it is. Sorry. So here it is. So this is what it's doing. So if you look at this cell, right? So this is actually how the sentences are represented, right? So, you know, probably I should have done like, be more realistic, right? And see what I'm saying? So these are the individual sentences. One sentence, another sentence, but represented as lists of ID. Got it? And then, so I'm going to run this one again. And then this A goes into this function sum that has this square bracket here. And I had to like search the definition of it, but it basically, that's what it does. It creates a list. It concatenates all of these. So you'll see the effect. See now, all of these are basically one single list. Okay, so that's kind of what threw me off a little bit. But once you understand that, then you know basically it just took all the text and created this really long list of IDs. And then it's just going to start chunking them. And that's it. Make sense? All right. So yeah, so that kind of, once you understand that, I think the rest of the code makes a lot of sense. We were here, I think. Yeah. Yeah. So if you notice, it's doing that right there. You see that? Some examples K and then that. So this is a list comprehension, as you know, in a dictionary. So a dictionary comprehension. All right. So it's doing this in there, right? The sum, and then it's concatenating the examples, basically. Then over here, it just takes a length, right? So it's calculating based on the block size. And I believe it says it drops like the last part. That's it. Okay, so it calculated some lengths, and then here basically it's split by chunks of max length. So you can see it's just doing a for I in range for 0 to total length block size. I'm sure you guys are familiar with this from I0 to N step, taking that little step. And then you can see here, this is just our very familiar, what do you call it? Slicing. Right? So it's just taking from I to I block size, grab that chunk, then from I block size, grab that chunk, but incrementing by steps. So step, step. You guys understand? That's it. So if you notice, I mean, it's actually not that complicated. Once it does that, it's created result. And then as I said already, takes result. Inputs are the inputs over here, makes them also the labels at the out, and they're the same. And they have not been shifted anywhere here. And so my understanding is it does the shift, the library does the shifting for you. Got it? Questions? That's it. So as you can see, straightforward. Yeah, doing this. Okay, now LM datasets is printed out. You can see it's got the labels. We've already explored the function there. Here's me just printing things in more detail. So, but I think hopefully this makes sense to you guys. That's just, as I said, everything, it's just breaking it out into parts. All right, and yeah, so that's kind of just viewing everything. Okay, so now you can view the data like that, different examples. There's IDs, so I printed these IDs. I printed labels. If you look, They're the same, correct? 198, 548, 198, 548, 301. You see that? But they will get modified inside, I believe. So the last one there, 209, 209. So it hasn't been shifted yet, but labels is the outputs and input IDs is the inputs. Questions? All right, great. So that's discussed. And then decoding basically, just so that you can see the actual string and you can see they're basically the same sentence. But at this point, they're like ready to go in to the trainer function of Huggingface. So note that that we duplicate the inputs to labels. This is because the model of the Huggingface transformers library applies to shifting to the right. So we don't need to do it manually. You see that? That's in their documentation. So you got to read for little things like that. Okay. When you're doing remember, you're doing RLHF, but through Huggingface. So you kind of need to understand their procedure. All right, then, yeah, this is just getting into the everything. Training, you can see that there. Notice I added the scratch space. And then when you hit this, notice you give it model, training arguments, train and validation, basically. And here, you run trainer.train, and there you go. It's going. So at this point, you know, it's going to run about 7,000 epochs. Yeah, that's kind of it. And then after that, in theory, it is trained, and you've got a GPT. You know, you're fine-tuned GPT, and then you just repeat the same process for. This is going to take a little bit, right? So this, although we're using a GPU, it takes a little bit. So I can discuss just the BERT one, similar. We've got a BERT base. In this case, remember, you either download GPT-2, BERT base case. So remember, when it says base, what does it mean? It's when they're talking about 7 billion parameters versus 65 billion, right? It's less parameters. So I think there's a distill BERT, which is really small. There's probably a BERT small, I don't know. BERT base must be like somewhere in the middle, and BERT large. Case means that it's got uppercase, right? So it means it considers uppercase and lowercase when it was trained. Whereas in other approaches, you might take all text and just make it lowercase. So and it would be uncase. Okay. So then you've got the tokenizer again. You add it. Notice datasets map. This is using the same dataset, so then it doesn't need to like load data. It's the same dataset. You tokenize it here. Training arguments, same as before. Don't forget the scratch option. Now here is, I did add this information because data collator, this might be a word. I wasn't familiar with this word before, but finally we use the special data collator, right? That's the thing that they are using. The data collator is a function that is responsible for taking the samples and batching them in tensors, right? In the previous example, we had nothing special to do, so we just used the default for this argument. Here, we want to do the random masking, right? Because it's a BERT, so it's a masking of the outputs. It's like fill in the blank, if you remember. So we do it, so here we want to do random masking. We could do it as a pre-processing step, like the tokenization, but then the tokens would always be masked the same way at each epoch. By doing this step inside the data collator, we ensure this random masking is done a new way each time we go over the data. So you can see it's like a thing whenever they want to do something inside the training process, they've created these things called data collators, which I remember when I read the RLHF code, there is one of those in there, right? So you'll need to pay attention to that. Yeah, please go ahead.
So I'm pretty sure the word that it is collator.
Oh,
But
collator.
if you think, so the way that it's used in like printing, which is probably where this originates
Mhm.
from, is like when you collate like a set of paper, what it does is like it'll print like 20 pages and then slightly shift it and then print 20 pages so that they're all in like the same stack, but like it's together but separate.
Mm.
Like if you like think of it in that way, it also
Like this.
yeah. So it like keeps it together but separate. And like it kind of sounds.
Collate. And what is that collate? It's like
What is collate?
Yeah.
It's like,
I know the math version.
oh my God, there's more versions.
Yeah, there are. And to collate is like, you get something like you did your 2D listing, you turn it into 1D. That's basically collating is you get a bunch of dimensions and you like squeeze it all into one dimension. That's when you collate the array.
Okay.
But like, it's not like collating is typically used for just like bringing a whole bunch of things
Yeah, you just get a
together.
bunch of things from many different dimensions and areas and then make it one, and they're all flat. So it'd be
Okay.
like, you get a 2D array and you turn it into a 1D array, and you basically would just squash all the elements.
Is it always squashing? Can it be like going in the other direction?
It depends on what type of collating you want to do, because then you can get advanced and be like, well, when you know, squeeze everything together, do you like, what if you have two elements that are the same number? Do you make it one, or do you have both the elements? Is everything in the same order, or do you have it like the first items and the second and the third? Like, how do you, so then it gets like.
So it's like a reorganization of
Right,
things.
it's an organization attempt, it's just how you do it is very.
All right, so I like that definition. So then these, if we want to define these data collators, right? For LLMs in the training, they are taking the data, grouping it, maybe processing it.
Right, so they would shrink the sentences down or make it like you have multiple sentences, maybe they just turn to one sentence, maybe they shift things around.
Well, what the example of the data collator here is doing the MLM probability, right? You see that? It's doing that MLM probability of 0.15.
Yeah,
So it's masking some of the words, some of the IDs, so that it predicts them. Yeah, so
okay.
I'm sorry.
I'm just trying to think like
Yeah, I don't know.
intuitively what it's
Or
doing,
it'd
but
be, like behind the scenes, they don't just hide the word, they remove it, like they swipe it out.
it might be like collators just to like process the data inside, group it, but then they also introduce other operations like the masking. Yeah, I mean, it's definitely something that we're all gonna need to read about as we start getting into the RLHF to get a sense of what it is. But yeah, good. Yeah, there you go. So any questions or comments on that? All right, great. So it's definitely something we're going to need to look into. All right. So as this says, by doing this step inside the data collator, we ensure this random masking is done in a way each time we go over the data. So it's grouped every iteration, every few iterations in a specific way, right? To do this masking for us, the library, Huggingface, I suppose, provides the data collator for language modeling, and we can adjust the probability of this masking, basically. So, yeah. I would say for now, my understanding of it, whenever you need to do something inside the training that organizes all these tensors, they do provide a definition here, actually. It says, the data collator is a function that is responsible for taking the samples and batching them in tensors. So we didn't create batches, actually, did we? So we just gave it all the data, I think. Well, we did define batch size here. Batch true. Batch size 1,000. So actually we did do that. So anyway, that's their definition. We'll have to dig deeper into what it is. But anyway, yeah. All right, so let's see where we are in the training. So it's still going. Okay. So after this, we were talking about BERT, if you remember. And basically here we initialize the data collator here. We've got the MLM probability. Then in the trainer, notice now you need to provide this data collator equal this thing that we just imported. And that basically goes into trainer. Training args was here, right? So training args, yes, is like before. And then here we have model args, train data set, eval data set, and now we have this new option that's being added, basically, in trainer. All right, and then you would run trainer and then just the performance, just like before. So that's pretty much it. That's the difference. So we'll definitely come back to that later. That's it. So hopefully that makes sense. This is, as I said, today's discussion was fine-tuning of a pre-trained model, either GPT or BERT, with definitely with the Huggingface library. Okay. All right. So I'll let this run. If you guys, we can basically stop. This will finish running and everything, and it'll look like this one. So I'm running this one, I believe. So when it finishes, I may not have printed this. When that one finishes, it's going to look like this, basically. So this is currently running, and you can see that the loss is going down 655 to 619 to 60. Okay, for the training set, and then you'll have a perplexity at some metric here, which is supposed to be low according to what they said. All right, so yeah, so that's basically it. My recommendation to you guys: repeat these exercises. Repeat the GPT part, repeat the BERT, do fine-tuning with Huggingface, maybe even load your own data, right? It's not homework, but just practice it. And then next week, we're going to come back and take a look at possibly some other task like classification or maybe a score or something like that. And then we're going to get started on RLHF, all right? But it's going to be a similar pipeline to this. And definitely, please start thinking about your mini project and what you want to do, okay? And hopefully by the end of next Wednesday, I'll set a deadline, like a date, because we're getting to the end, actually, of the NLP section of this course, okay? So the RLHF will be the last topic, basically. As we have done pre-training, we've now done fine-tuning, and then all that's left now is special cases of predicting classes or scores and RLHF. So really at this point, it's all Huggingface. After we finish this section, I will cover CGANs and reinforcement learning just a little bit, and then we're going to move into the other big area of transfer learning, which is images, ResNets, and then we'll use the Fast AI library to do something similar to this, but for images. Any questions? All right, great. So you've seen what the output will look like. I think it's still running. So I'll stop the video here. We can stop at 6:13. So if you want, let's take the 10-minute break now, and we can start the exam at 6:23. All right, great. Stop the recording.